Okay, so about another example of the tetrahedron. So I give you another example. We have z equal to 6 minus 3y plus 2x. Plus 2x. Okay, so how many variables that we have? 3, right? So how many traces? 3 traces. Okay, so now we set when x equal to 0. When x equal to 0, so the equation become 6 minus 3y. Okay, or in a standard form of linear equation, we have minus 3y plus 6. Okay, so the sketching, now we have zy plane, we have negative slope, intersect at z6. How about on y? So on y we z equal to z equal to 0 minus 3y plus 6. So 3y equal to 6, y is 2. So we got 2 here. Okay, so that is the first one. So the next one we set, let's say I put y equal to 0. So the equation becomes z equal to 6 plus 2x. Okay, so in this case, we have the line which is lying on zx plane, and we have a positive slope, the graph like that, and at z we got 6, and when z equal to 0, so the value of x becomes x minus 3. And then the third one, z equal to 0, z equal to 0, so 0 equal to 6 minus 3y plus 2x. Okay, now you need to modify. So we got 3y equal to 2x plus 6. Then y equal to 2 over 3x plus 2. Okay, so now for this, we have a positive slope as well. Y-x plane, on y-x plane. Okay, so the intersection on y, we got 2. And then how about along the x-axis? So we have to set y equal to 0. 2 over 3x plus 2. So 2 over 3x minus 2. 2x is minus 6. Then x equal to minus 3. Okay, so this one is minus 3. So based on the 3 traces that we have sketched, then we have to combine them all together on the same 3D system. Okay, so the first one, the first trace, we set x equal to 0, meaning that you are, okay, let's say first I'm choosing the I put in standard form of the orientation. Okay, y. Okay, so the first one, x equal to 0, meaning that you are lying on x plane. So on x plane, you are here. So what can you see on zy? Z versus y. So you can see a red line, and the intersection is at 6, 2. Okay, now we move to the second trace where y equal to 0. Y equal to 0 means you are sitting or standing on along the y-axis. So the next, you are here, and you look at over there. Okay, and you can see the line on zx. So okay, so your x is negative, So I put that negative. So that is for negative x. So let's see. That is the negative x, which is minus 3. So I draw this line. So the line is over there. 6 minus 3. Okay. And you can see that the point here intersects each other, right? And this is minus 3. And then I move to the last trace, which is z equal to 0, meaning that now you are standing over here and you're looking down and on y-axis plane. So this is the line that you can see, which is y is 2. Okay, y is 2, and x is minus 3. And you draw the line. That is the line. Okay, so your plane is tetrahedron. So that is your plane. Okay, so your plane is actually flat plane, and it is passing through on the wall here and the wall of zy plane and the floor of xy plane down here. Okay, but remember this is just a flat plane. But let's say you said that the tetrahedron is bounded by all the coordinate planes. So meaning that you can have the wedge, bongkar. Okay, so it's not just like a single surface. But for this particular example, we just sketch the plane. So the plane is this one. Where if I draw it, so that is your surface or plane. Okay. If you are still confusing about what is the tetrahedron, so you can just go googling. Just use the keyword of how to sketch tetrahedron. Okay, so there are very many examples in the website. Okay, so now so far what we have done is sketching how to sketch a plane where the variable okay, so refer to the notes here. So we have done sketching all this particular plane and all this particular equation where we have a single variable here and we have total variable is 2 and the total variable is 3. So as mentioned before, each of them I split them into 3 parts because the way you want to obtain the plane is a bit different. As you can see, for example, that we have discussed on this particular example, this one, if you have the total variable is 2, there is only one single trace. But if you have total variable is 3, so you need to provide the 3 traces. For one trace, when you have one trace, then you must obtain the projection. Must have projection. And also to complete the sketching, to get the plane, you must draw or sketch the projection line. Okay, but for 3 traces, you don't have the projection. For 3 traces, you have to combine all the 3 traces into a single 3D system. So about the 3 traces, there is no projection. So you have to bear in mind, okay, you have to always remember. So this is very important thing. Okay, 3 traces, you don't have the projection and also projection line, but you have to combine all the 3 traces on a 3D system. Okay, on the similar 3D system, then you can obtain the graph on 3D. Okay, so the next is we want to, so we've done this. So this is actually how you can obtain. So I already explained indirectly. Okay, so that is Okay, so the next is curvy surfaces. Okay, so curvy surfaces. So for curvy surfaces, before I provide more complicated curvy surfaces, I want to focus on the sphere surface. Sphere. What is sphere? Just like a ball. Okay, a ball. You can touch the ball. So that is an example of the sphere surface. So this is the general equation. It's just like circle. Okay, if you have circle, what you can do here, if you have only this one, x and y, then you have a circle. On 2D, you have a circle with radius 2 and centered at 0, y 0. And your circle is lying on y-axis plane. Or maybe you have only this one, x and z equal to r squared. So you have only also a circle with the similar radius r. The center is at x equal to x naught. At y, at z is equal to z naught. But your circle now is lying on xz plane and so on. But since you have a 3 variable here, so you have surface, and this particular surface is called sphere. Okay. The simplest example. So here I provide you the example. So let's say you have x squared plus y squared plus z squared equal to 9. So we can say that the center here, so if you compare with the general form, so this one is 0, and this one is 0, and this one is 0. Okay, for this particular example. And your r squared is 9. But then your r is 3. Okay, r squared is r squared. R is radius. So when the value here is 9, so you have to find the square root. So the square root of 9 is 3. So you can say that in this case, for this example, the center is at 0, 0, 0. Okay, how can you sketch the sphere with radius 3 and the center at origin? So we call this as origin. So this is called origin. So how can we sketch the sphere with radius 3, center at the origin? Then of course you need to provide the traces x, y, z. So x squared plus y squared plus z squared equal to 9. So how many traces that we have? Sorry, how many total variable that we have? So we got 3, right? So 3, so meaning that how many traces that you have to provide? Also 3. Doesn't matter whether this is linear or non-linear equation, so the step should be the same. So now you have to provide the traces, which means that you have to set x equal to 0. So it's become y squared plus z squared equal to 9. So your graph is circle. So circle with radius 3 on zy plane, centered at the origin. Okay, we go next. Next, y equal to 0. So y equal to 0, we have x squared plus z squared equal to 9. Then when you sketch that, so you have a similar size of circle. Also, circle centered at the origin. The center is also 3. Now on zx plane. And the third one, we set y equal to 0. So y equal to 0. So you have, z equal to 0. Z equal to 0. So you have x squared plus y squared equal to 9. Then when you draw the line, the graph, so the graph is also a circle with radius 3 centered at the origin on y-axis plane. So when you join them together, when you are standing on X, you see the circle, and then you just move around. You can still see the circle, and when you go up and looking down, you can still see the circle. So circles, circles, circles everywhere, then you can have sphere. So now that is our imagination, but now you have to write on the paper by hand. So how can you do that? Okay, so we do one by one. So first we set x equal to 0. When x equal to 0, you are standing over here and you looking that side. So you can see a circle. So a circle with radius 3 and center at the origin. So meaning that your line here should be extended. Okay, so firstly, so I'm sketching the circle where you can see from this side. A second. Okay, when you can see from this side, you can see the circle. Which circle? This circle. Okay, I should draw the same color. Yellow. So now I have yellow. So I draw the yellow circle. So at Z it is 3. On Y it is 3. So you can see from this side. Okay, imagine now you are over here. Okay, next, Y equal to 0. Y equal to 0, now you have orange. Okay, so the orange over here on Z, ZX, okay? ZX. So what is ZX? ZX. Okay, so on Z, it is 3 minus 3. So now orange. Minus 3. So here, and this is minus 3. And at X is 3 and minus 3. So let's say here is 3 and back here is minus 3. So now we draw this one. Because this is your vision from this side, yeah? So it is a bit compressed. Okay, be careful. Your imagination should be follows where is your location now. So now we are talking about the ZX plane. So now that is for X positive, so X negative should be behind there. So that is also circle actually, but it looks compressed because you are looking from this side. So from this side, you can see the yellow one is a bit bigger because you can see in front of here. Okay, that is the second trace. Now the third trace, trace is this one. Okay, 3, 3. So Y-X plane. So it's happened when you are standing here and you're looking down. So on the Y-X plane, so your Y-X down here, so you have Y3 and you have what else? X3 and X minus 3 and also Y minus 3. So now you draw the purple line, the purple circle. So touch this line, and also. Okay, remember you are looking from this side. Then that is your sphere. You need to practice. So easy for you to say that, okay, sphere, it should be a ball. Yes, it is very easy to be imagined, but it's not so easy to be sketched by hand. So you have to practice. You know what? When I give a student, let's say I give a question in exam or test, I can see the student, they either try to have some practices on the sketching of the sphere or not. Because you know what, when I would say that some of the students who did not practice on sketching the sphere, so they just give me this particular graph because they know that the traces, 3 traces, give them 3 circles. So you have to combine all the 3 circles and they give me this 1. And the second circle 2. And the third circle 3. That's it. Is this one called sphere? No, this is not sphere. I know you are trying to tell me that you want to sketch a sphere, but this is not sphere because you are not spend some time practice to sketch the sphere. Okay, so that is for the sphere. Okay, so let's go back with whatever in the notes here. Okay, so now we have another example. Okay, we are having the x minus 3 square and then y plus 2 square and z minus 1 square equal to 4. So now you're back to the general form of sphere. So in this case, I'm talking about this example. So your x0 is 3 and then your y0 is you have positive here, meaning that y minus negative 2. So that's why you have y plus 2. So now your y0 is minus 2. And the third one here is z0 is. So you know that your center is located at 3 minus 2, 1. Which is x equal to 3, y minus 2, z equal to 1. And how about the center? The center is... So the center of the sphere, okay, this is the center, 3 minus 2, 1. How about the radius? So the radius is 4. Sorry, the radius is 2 because r squared is 4, so r is 2. Okay, so before we do a practice on sketching on this particular graph, so just look at the example provided here. So we have done sketching this just now, the sphere with radius 3 centered at the origin. So now we look at the B. Okay, so what is the information that you can obtain from this equation given? So we have what you can say about this. So the center of the circle is located at 3, 0, 0. How about the radius or r? Radius is 2. Okay, now for the origin just now, okay, before we proceed on the example B, we look at the example A just now that we have discussed. So you can see that this one is a sphere where the center is at the origin and the radius is 3. So doesn't matter what is the value of the radius is, but we just look at the center. If your center is at the origin, which is x equal to 0, y equal to 0, z equal to 0, so in order for you to provide the trace, should be always on x equal to 0, y equal to 0, z equal to 0. Okay, where we have done that, where I have provided here. So when the origin, so you can see that the sphere is at the origin, so we just set up x 0, y 0, and z 0. Okay, what you can say that the graph is passing through the front wall, the left wall, and the floor. Okay, because you know that they are centered at the origin, and the graph should be can be lying along the coordinate planes. Okay, the coordinate plane which is x equal to 0, y equal to 0, and z equal to 0. So these three is actually coordinate planes. We said z equal to 0, y equal to 0, and x equal to 0. But for this particular example, it is a bit different in terms of providing the trace. So you cannot say that the trace should be on x equal to 0 and y 0 and z 0. So it depends on the center that you have. Okay, look at here. The rest, they are on the y0 and z0. Only the x is 3. So, in order for you to provide the traces, we try to provide the traces. So, how many traces? Should be 3 because we have total variable is 3. So, okay, now we are talking about the x minus 3 square plus y plus 2 square plus z minus 1 square equal to 4. Okay, so just like the previous one, we set x0, y0. Okay, the previous example, x equal to 0, and you want to see what happened, the trace looks like. And then we set y equal to 0, and you check the curve looks like, and then z equal to 0. So this one is only when the center is at 0, 0, 0. Okay, so in this case, the center is at 3, 0, 0. So we can see that for y and z, they are on the y0 and z0. So this is okay. You can choose y equal to 0, and also you can choose z equal to 0. But they are passing through this particular plane, which is coordinate plane. But this one, the graph is not symmetrical or passing through at x equal to 0. I would say that symmetrical, okay? They are not symmetrical at x equal to 0 because it shifted somewhere. Okay, it's no longer, the center is no longer at the origin. So it's shifted to x equal to 3. So you cannot set x equal to 0. So your trace must be a problem. If you set x equal to 0, then your sketching is just got nothing. Okay, you cannot join them all together. So that's why in this case, because the x is shifted to x equal to 3, then here you have to choose x equal to 3. Okay, you cannot, in this case, you cannot put the x equal to 0. So you can try to put x equal to 0, but then after you want to combine them all together, just your sketching is not in the correct order. Okay, so let's say first we set x equal to 3. Okay, so now by setting x equal to 3, so your equation here becomes y plus 2 squared plus z minus 1 squared equal to 4. Then you got a circle with radius 2. Sorry, I just realized that I copied the wrong question. So the original question is just this one. Okay, sorry, I just resketch here. I just rewrite. Okay, so you have y square plus z square equal to 4. So this is not correct as well. Okay, now you replace x equal to 3, then this one becomes 0. So you have only y square plus z square equal to 4. And then when you set y equal to 0, this one becomes 0. So you have x minus 3 square plus z square equal to 4. And for the last one, you set z equal to 0. So you have x minus 3 square plus y squared equal to 4. So these are all circle, but the center is different. Okay, when you are standing along x at x equal to 3, not x equal to 0, but along x equal to 3, then you can see a circle with radius 2 and center at the origin of this particular equation. Okay, so zy plane, and this is 2 and this is 2. And then the second graph on zx. Okay, now you can see that the radius is the same, which is the size of the circle still the same, but it shifted at x about 3 units to the right, isn't it? 3 units to the right. So your center is now at 3, 0. So 1, 2, 3. So 3. So now, how about your shape of the circle? Is it passing through the origin? So now we check. So we know that from here the radius is 2. So that is your 1, 2. So this is 5. Okay, and 1, 2, 1, 2. So that is your circle. So now you can see that your circle is no longer passing through the origin. So okay, now when you are standing at y equal to 0, so on the x plane you can see the circle where the center is at 3, 0. Okay, no longer at the origin. So now we look at the third one. The third one, so now you have yx, the radius still the same 2, but now your center also at 3. So 1, 2, 3, 4, 5. So radius 2. So 1, 2, 1, 2. This one and that one. So now this is your circle. Actually, the circle for this and this, they are the same. Okay. But the scale is a bit larger. Okay, but they are the same circle, the same size. Alright. Now you have to combine them all together on the 3D system. Okay, so let's say I have the general form. This is Y, the general orientation, and this is Z. Okay, look at the first one. So you said that when you are standing, you are standing x equal to 3. You are standing along the x-axis, but not at x equal to 0. You see, x equal to 0 is the wall over here, right here, over here. That is for x when you set x equal to 0, but now you set x equal to 3. So find where is the x equal to 3. So 1, 2, 3. So here. So when you have x equal to 3, so that is your circle. Where is your circle should be in? Okay. So now you draw the circle on the ZY plane. So you can see the circle with radius 2. I would say 1, 2, 1, 2, 1, 2, 1, 2. So I just combine. That is the circle. Okay, so this is 2, and this is 2, and so that is -2. Okay, -2, and this one is somewhere at the back over here, and it is -2. Okay, so that is the circle of this blue one. Okay, now I redraw, because we set the circle is located on x equal to 3, not x equal to 0. Then you should bring forward. Okay, you are over here. So now you can see the circle when at x equal to 3 plane. So it should be here, not at the back. Okay, now y equal to 0. So this is y equal to 0. Now you are looking from this side, and your sketching should be on the y equal to 0 plane, which is your left wall, your side wall here. So you can see the similar circle, the same circle, this one, the green one, but not passing through the origin, isn't it? not passing to the origin. So you can see that on Z plane here, you can see the Z, the value is 2 and minus 2. So you can see the Z here, 2. So your green should be passing to that point, and the point down here, and then so this one should be 1. So you can see this one, 1, and this is 5. Okay, no, 0, not 0, but 1 and 5. So 1, and then at the back, so this is supposedly, I would say this one is 5, and here should be 1. Okay, and then where is the yellow circle, which is on y-axis plane? Y-axis plane. So y-axis plane down here, this is x, this is y. So at x, you can see this is 5 and this is 1. So we have now orange color, 5 and 1, and then on y is 2. So this is 2 minus 2. Okay, so on y-axis 2 and minus 2. So now we put the point y2, so this one and this one. So you draw the line, y and the other circle. So then this is your sphere, where the center now is at 3, 0, 0. This is the center. And then radius is 2. Okay, so if you still feel this one is very complicated for you to follow, then again, resketch. Okay, replay the video and resketch.